Hey, ninth graders, we are on page 91 in your math binder. It is called writing functions. So let's first of all talk about the different types of functions that we learned about. Last unit, we talked about arithmetic sequences and geometric sequences. And some of you might have the formulas, if you remember those from from last unit. The explicit equation for an arithmetic sequence, we said, was f of n equals f of 1 plus the common difference times n minus 1. And that was something that we used for our general form in the last unit. Geometric sequences, our explicit equation was f of n equals, and then we said the first term times r to the power of n minus 1. Well, we are going to look at these when they are linear versus exponential now. So when we have a linear equation, the only thing that we're going to see that's slightly different is we still start out with f of n, but we're actually going to call it f of x. Here's why. Because when we're doing these, we're not talking about the number of term. We're talking about an input of whatever the x-axis value would be. So that's why we say f of x on these. Then we always take whatever is being added, our rate of change, and we call that d. And then you multiply that times x. And then on the end, we always add f of 0. Well, what is f of 0? That's just the starting point. So another thing that we sometimes call this is y equals mx plus b. That's what these equations are looking like. But you have your starting point being added on the end and your change, your rate of change, being multiplied in front of x. Now for the exponential equation, it looks like this. F of x equals, and then you start this one with your y-intercept, your f of 0. And then you multiply it by whatever your change factor is to the power of x. So you'll see that we change it from f of 1 to f of 0, and instead of n minus 1, we just have a simple x. So I actually think that you'll find these to be not as difficult as they might have been last unit. So for both of these things, over here on the side, I'm going to even put this in simpler terms. You need to know. All right, need to know, ... And this is the same stuff that I have on the board in class right now. 1, you need to know where it starts. And the thing about where it starts is that is always going to be the y-intercept. The second thing you need to know is how it changes. And how it changes is either going to be the rate of change or the change factor. So you find where it starts, you find how it changes, and then when it is a linear equation, you can say that f of x equals, and on this one we do the change times x plus the start. For exponential, we say f of x equals, and these ones, because it said f of 0 is at the front, we say the start times the change to the power of x. And that's what this looks like. Okay, so I'm going to use this stuff on these problems throughout this homework assignment. So we are going to be finding where it starts and how it changes on every problem. So let's start with number 1. Where does number 1 start? Well, my y-intercept is right here. It starts at 1. And then how does it change? Well, it goes from 1 all the way up here to 5. So how do I go from 1 to 5 with multiplication? Because clearly this is exponential. It's got a curved graph. Well, from 1 to 5 with multiplication, I need to multiply by 5. And if it's on the right side, that is your change factor. So let's write our equation. Our equation for this exponential function is going to be f of x equals the start times the change factor to the power of x. So f of x equals the start, which was 1, times the change factor, which is 5, to the power of x. No, don't type it in the computer like that. Just type in 5 to the power of x. And that's all. Super simple. Let's look at problem number 2. This one is linear. So I'm going to put the change in front of x and then add the start. So let's see. This one starts at 1. There's my start. And the change here, it's going down 1 space to the right 1. So m equals -1 over 1, which is -1. So I have my start. I've got my change. Let's write the equation. It's going to be change times x plus the start. So f of x equals the change, which was -1, times x plus the start, which was 1. Super simple. All right, let's look at one more together. We'll look at problem number 3. On problem number 3, I can see that this one starts, oh boy, that's hard to see. I think it starts at 5. And then the next good dot is up here at 10. And then it goes up to 20. So how do I go from 5 to 10?
Turn the canvases down, Mr.
Canvas is down.
You can leave. If you have to work on it from home tonight, then you can do that. But you can leave now. Thank you.
I don't know if you heard that announcement, but I was just given permission to leave school. But I'm going to stay and finish this video because I'm such a nice person. Okay, so from 5 to 10 to 20, I am multiplying by 2. There's my change factor, and my start was at 5. So let's write our equation. For exponentials, I do f of x equals the start times the change factor to the power of x. So f of x equals the start, which is 5, times the change factor, which is 2 to the power of x. And that's all. I want you to push pause, and you are going to do problems 4, 5, and 6. Push pause and actually do them. Okay, on problem number 4. Ooh, this one's kind of weird. I hope you didn't say that this was the start, because the start is at 0. I need to get this graph further back. Fill in my grid, and it looks like this graph started there. So where did it start? It looks like it started at positive 2. And how is it changing? Well, it goes down 2 to the right 6. So m equals -2 over 6, which is -1/3. So when I write my equation, change times x plus the start, I will say f of x equals my change, which is -1/3, times x plus the start, which was 2. On problem number 5, I can see that this one starts at 3. Now I cannot see on the fraction side, the smaller side. That's really difficult to find where it changes. So I'm going to go the other direction. I'm going to say 6, and then we have a dot at 12. So from 3 to 6 to 12, I'm multiplying by 2. Ninth graders, that is not your change factor. 2 is not your change factor. Change factor has to multiply to the right. So I need to figure out 2 over 1, flip it. That makes my change factor 1/2. It has to be on the right. So f of x equals the start times the change to the power of x. So I will say f of x equals the start, which was 3, times the change, which is 1/2, to the power of x. All right, one more. This one starts at, I'm just going to guess it starts at 1/2. So we've got 1/2 for the start, and then it goes up to 1 and up to 2. That is multiplying by 2 for my change factor. So it's an exponential function. I say f of x equals the start, which is 1/2, times the change, which is 2, to the power of x. So f of x equals 1/2 times 2 to the power of x. Ta-da! Okay, so let's look at this next one. I'm going to start by figuring out, is this a multiplication pattern or an addition pattern? -4 to -11 to -18 to -25. It's not growing big enough to be a multiplication pattern. It looks like it's just subtracting 7 every time, in fact. And if I look at that, I can see that it's subtracting 7 and adding 1 every single time. So that would make my slope -7 over 1, which is just -7. So the next question is, where does this one start? It's wrong if you say -4. That is not the starting point. That's where the table starts, but that's not the starting point of this function. The starting point on a function is f of 0. This is f of 2. So I need to take my table and extend it back so that it includes 0. So the number before 2 would be 1, and the number before 1 is 0. And I have to work all this other stuff back to fill in the blanks. So if it subtracts 7 going this way, I need to add 7 to go backwards. So -4 plus 7 is 3. Plus 7 is 10. So there is my starting point, 0, 10, which we can just say as 10. So if this is linear, I have the change in front of x, so that'll be -7 is going to be in front of my x, and then the start is being added on the end, which is 10. So I will say f of x equals the change, which is -7, times x plus 10. Okay, on this next one, this is clearly jumping down very, very quickly. That is a typo. There's no way it can be 12 and then 12 again. That is supposed to be 48. Okay, so what's being divided there? What is being divided every single time? How do you go from 3,072 to 768 to 1,092 to 48 to 12? I don't know, so I'm going to divide it the other way. 12 divided by 48 is 1/4. And then 48 divided by 192 is 1/4. So my change is multiplying by 1/4. And where does it start? Again, you can't say -5. In fact, we can't even extend our table to the left, because then we'd have -6, -7, -8. It's not going to work like it did last time. Where do we extend our table to get to 0? Well, over here it's at -1. I'm going to extend in this direction. And we would have 0. So 12 divided by 4, or times 1/4, would be 3. And there is my starting point. Back to my exponential equation format, f of x equals, and then I have my start, which was 3, times my change factor, 1/4, to the power of x. Beautiful. Okay, this next one. Look at these last two problems. They almost look identical. However, one of them is asking you for a linear function that passes through 1, 5, and 2, 15. And the other is asking for an exponential function. Big difference here. Let me explain why this is such a big difference. I'm going to make a table, x and y. Now notice my x coordinate is 1, my y coordinate is 5. So I have 1 and 5 for an ordered pair, and I have 2 and 15 for another ordered pair. But the problem is neither of those has an x value of 0. So neither of those will give me my starting point. I want 0 in this table. So I'm going to actually put 0 at the beginning, and then I can put the 1, 5, and the 2, 15. Why did I do that? Because I want to be able to extend my table in the other direction. So how is this thing moving? Well, it says that it is linear. That means we need an adding pattern. So what is an adding pattern to go from 5 to 15? Well, from 5 to 15, I add 10. And up here, I'm adding 1. So I need to find something else that when I add 10, I get positive 5. What number goes in that blank? You could subtract 10. That would help you get to that blank. 5 minus 10 would be negative 5. So ninth graders, there's my start, and this is my change. This is a linear equation, so I'm going to do the change times x plus the start. F of x equals 10x. I could say plus negative 5, but I'm just going to write minus 5. There you go. There you have it. Let's look at one more. This one's asking for the exponential function. Now, I've got the same ordered pair. I'm going to set up the same table, but it's not going to fill in with a negative 5. I'll have a 0 there. Then I'll have 1, 5, and 2, 15. But this time, I need to find a change factor. So I'm not adding 10 because this one's not linear. This one told you that it was exponential, which can work because you've only got 2 ordered pairs. So to go from 5 to 15, I multiply by 3. Now, this is the tough part. What number can I put there that when I multiply by 3, I get 5? Try doing 5 divided by 3. You get a repeating decimal, but just keep it as a fraction. You have 5/3. So my exponential equation, f of x equals the start, which is 5/3, times the change, which is 3, to the power of x. Wonderful. All right, and that is today's notes. Let me know if you have any questions or if you need any help on this stuff.